Let's begin by talking about multiplication of complex numbers. Now we're talking about powers of complex numbers. So in the case of powers of complex numbers, right, we're taking the same thing and we're multiplying it twice. So, thusly as such, we're taking, let's say z is equal to r cosine of theta plus I sine of theta, multiplying it by itself. Okay. So z times z is of course z squared, which using our formula is r cosine theta plus I sine of theta, and then times r cosine of theta plus I sine of theta. And from here we have two r's, right? So this becomes r squared. Cosine of theta plus theta, because we add the angles. And we end up with some really nice expression of r is equal to cosine of 2 theta plus I sine of 2 theta. Okay. And to continue this kind of theme, it works whether I'm multiplying it 3 times, 4 times. This is kind of a deductive proof, so to speak. This isn't really proof. The proof for this theorem we'll do later when we get to induction. We'll talk about it. I'll do this proof then. But for now, I'm just going to show it as a derivation kind of way. And so if I take z to the second, multiply it by z, again, I get r squared cosine of 2 theta I sine of 2 theta times r cosine of theta I sine of 2 theta, which, using our product rule, multiply the moduli together, r's and r's, r squared, r1, r3. We add the angles, cosine 2 plus 1 is 3. Now in general, this happens to be true. And in general, this happens to be true, and it is named after some French dude named Abraham Demoivre. So it's called Demoivre's theorem, and I will state it for you here. And the formal proof for this takes something that you have not learned, which is called induction, unless they taught it to you in Algebra 2, which most teachers don't get to. So it's Demoivre. His name is French. Okay. And so it states, if z is equal to r cosine theta plus I sine of theta is a complex number and n is an integer, then z to the n is equal to r cosine of theta minus sine of theta to the nth power, which is r to the n cosine of n of theta plus I sine of n times theta. And so that's Demoivre's theorem. Sounds fancy? Not really. So to translate that into English, what it means is you take the moduli, raise it to whatever power. So you raise the moduli to a certain power. After you do that, then you multiply angle by the power. Easy enough. So now, let's do example of that simply. Let's do example of this one. So let's find one plus I to the fourth power. Now the first thing we have to do in this problem is, of course, switch it to its trigonometric form. So we switch it to the trig form, of course, by using Pythagorean's theorem, which is r is equal to, the moduli is equal to r of a squared plus b squared. Of course, a equals b is equal to 1. Lovely. So that's equal to square root of 1 plus 1, squared, close bracket, close bracket. So that ends up being the square root of 2. So r is the square root of 2. From here, we need to know the angle. So theta equals arctangent of b over a, which is arctangent of 1, which is pi divided by 4. So we have theta is equal to pi over 4, r is equal to square root of 2. Now, you could have known that because we did the same example earlier, but that's okay. So then we plug it into the trigonometric form. So then from here, we know that r is square root of 2, so it becomes r cosine theta plus I sine of theta. So it's equal to square root of 2 cosine of pi divided by 4 plus I sine of pi divided by 4. Now I need to raise it to the fourth power. So in part C, we're going to use Demoivre's theorem. Okay. That's a horrible looking theorem. Let me write it neater for you. There we go, better. Now, so this whole thing gets raised to the 4th power. So square root of 2 gets raised to the 4th. And then we know that the power gets multiplied by the angle. So 4 pi over 4 by sine of 4 pi divided by 4. Kills that. That kills that. Square root of 2 to the 4th is, of course, square root of 2 to the 4th power is 4. Because square root of 2 times square root of 2 square roots cancel. Then you're left with 4 on the inside, thus getting you 4. So this becomes 4 cosine of pi plus pi is sine of pi. Sine of pi is nothing, and cosine of pi is -1. So this becomes -4 as the answer to this question. Okay, very good. So good, we'll do another one. And then on to example 2. Find 3 plus 3 square root of I to the 7th power. So the same solution, we need to convert it once again. So the same solution applies here. We need to change it. Of course, so thusly, this becomes r square root a squared plus b squared. 3 squared is 9. 9 times 3 is 27. So this becomes square root of 3 squared plus square root of 27 squared. So this becomes 9 plus 27 is square root of 36, which is 6. Okay. And then from here, figuring out the angle. Of course, theta is arctangent of b divided by a. Is arctangent of 3 square root of 3 over 3. That kills that. We end up with arctangent of square root of 3, which is pi divided by 3. Okay, so we have r6 theta is pi over 3. Plug those in. So we plug into the trig form, which will be so 6 cosine of pi divided by 3 pi over 3. First quadrant. Now, from here, we use Demoivre's theorem. And I'm not going to. So from here we use Demoivre's theorem. So to use the theorem, which is going to be r to the n cosine n theta plus sine of n theta. So this ends up being 6 to the 7th power times cosine of 7 pi divided by 3 plus sine of 7 pi divided by 3. Now, if I was a jerk, I would make you figure out what 6 to the 7th power is. And I am. So, 6 to the 7th power, there is a way to do that without really trying to do much calculations. Yeah. One thing you learn how to do things in your head, 2 times 3 to the 7th, 2 to the 7th, 2 to the 5th is 32, 2 to the 6th, 2 to the 5th is 32, 2 to the 6th, 54 to the 7th is 128, and times 3 to the 7th power, which breaks down to, of course, 3 to the 3rd, this is 128. I would use a calculator to do this, but I'm tired and don't feel like using a calculator. So, it's 128, 3 to the 7th, 3 to the 3rd times 81, so it's 81 times 27. So 81, 27, 7, 56, 32, 16, 7, 8, 1, 1. 2167 multiplied by 128, which will be 6 carry the 5, so on and so forth. There's faster ways to do this, but I'm tired and don't feel like doing that for you. So 6 carry the 5, 8 times 8 is 64, 64 plus 5 is going to be 69. Carry the 6, 8 times 1 is 8, 8 plus 6 is 14. Carry the 1, 2 times 6 is 16, 16 plus 1 is 17. And then you end up with 2. So I'm going to go ahead and cheat. 187 times 2 is 4. 14 carry the 1, 8. 8 times 2 is 16. 16 plus 1 is 17. No? Yeah. Agree? It is 17. And then carry the 1, so it's 374. So that's going to be 14. 14. It's going to be 374. Actually, screw it. We'll just use a calculator. I want to do it in my head, but I'm tired. And my brain's not cooperating with me. So, therefore, 6 to the 7th power is an hideous ugly number. You can leave it like this. Okay. Yep. Calculadora. And 6 to the 7th power should be a little bit. Yep. 6, the 7th, is 27,936. So, should have known that, but that's what I get for being tired. Okay, so over here, this is 27,936. Or 99.36, sorry. There you go. And that's his cosine of 7 pi divided by 3 plus I sine of 7 pi divided by 3. Okay. Alright, easy enough. Now, let's see. I've yapped my mouth enough. So on the next one, we'll talk about nth roots of complex numbers.